Hey, just an addendum to the video. I realized that I never showed you what subtraction looks like with elimination, because you can still do subtraction instead of an addition problem. Sometimes the equations won't look nice. In this case, it does with x, but sometimes it won't look nice. You'll have to subtract the equation instead. So in this case, I'm going to subtract with the purpose of eliminating y instead of x. And if we follow the same logic as before, right, we converted our equation. We can subtract the entire equations. You get a negative and a negative x, so it becomes a positive x. You end up getting 13x. In this case here, we get 24y minus y. We end up getting 23y, and then we get 0 minus 20, you get minus 20, and 780 minus 0 is 780. So it doesn't really help us, right? We get in the same situation as before with a really ugly equation. We have to multiply our second equation, in this case, by something so that we can actually eliminate something properly. And that something is the y. I have 24 red ones, so I need to have 24 blue ones, and they have to be negative in order to subtract them. So that means that I must subtract 24 times my blue equation. So I'll put the 24 in, and I'll do some of the math here so you can see what the numbers look like. All right, so the math brings you to something like this here. You end up with negative 24x plus 24y plus 480 equals 0. Now, when I subtract my blue equation, I know that my 24 will cancel out with my 24, so I'll lose my y's, which is what I want to do. I want to eliminate them. You have a choice at this point on how you want to do the math. You can either subtract the second equation, or you can multiply this negative into every single term of your blue equation, and then it becomes an addition problem. I'm going to do it that way because that's how I do my subtraction, is I multiply my negative into my brackets first. I make less mistakes when I do addition, and you guys will make less mistakes by doing addition as well. But if you're more comfortable subtracting that blue equation, you can do that. Okay, so to see how I did it with subtraction is by putting that negative into my brackets, it flips every single sign. So my negative 24x becomes a positive. My positive 24y becomes a negative. My positive 480 becomes a negative. And then 0, you can't really flip the sign because there is no sign. The reason why I like that is now I just read downwards and I can solve. 12x plus 24x is 36x. 24y minus 24y gives me nothing, so I shouldn't have any y's left over. And negative 480 doesn't have a partner, so I'm just left with negative 480. Lastly, I have 780 plus or minus 0. It doesn't make a difference. I'm left with 780. Now, if I move this 480 over to the other side, it means I have to add it to the other side, right? If I have a negative on one side, I have to add to both sides to move it over. I end up with 36x is equal to 1260. Divide both sides by 36. That will isolate x, and then ends up being 35. To solve for y, we can use one of our equations just like we did before. We'll have to rearrange it a little bit, but we can plug 35 in for x, and the only number y could be then, if we add something to 20 to get 35, it has to be 15. So it means that we get the exact same solutions no matter which way we do it. So you remember when I said, like, elimination, substitution, systems of linear equations are really cool? This is what I think is really cool about them, is we can approach them in so many different ways, and we get the exact same solution every single time. That's insane. That's why it's cool to me. Anyways, here's the practice again. You can give that a try, and I'll see you in the next set of videos where we'll look at substitution part 2 and elimination part 2.